Have you ever wondered if NASA has worked on projects so advanced that most people have never even heard about them? When we think of NASA, we usually imagine astronauts walking on the moon, powerful rockets launching into space, or futuristic missions exploring Mars. But behind the scenes, NASA has spent decades developing experimental technologies that were once hidden from the public. Some of these projects involved nuclear-powered spacecraft capable of reaching distant planets in record time. Others explored military spaceplanes, classified missions, and revolutionary engines that could completely change the future of space travel. While many of these programs were eventually canceled or declassified, their ideas continue to influence the next generation of space exploration. Today, we're counting down 7 of NASA's most fascinating secret projects that push the boundaries of science and engineering. Let's begin with number 7, NASA's future deep space nuclear propulsion concepts. Traveling through space is incredibly slow. Even our fastest spacecraft can take months or even years to reach nearby planets, while missions to the outer solar system can last decades. To solve this problem, NASA has been researching advanced nuclear propulsion systems that could dramatically reduce travel time. Unlike conventional chemical rockets, which burn fuel quickly, nuclear-powered engines generate enormous amounts of energy from atomic reactions. This allows spacecraft to produce greater thrust while using fuel much more efficiently. For decades, many of these concepts remained largely unknown outside scientific and government circles because of their complexity, national security concerns, and the challenges of handling nuclear technology in space. Engineers believe that future astronauts traveling to Mars or even farther destinations may rely on these advanced propulsion systems. The advantages of nuclear propulsion are remarkable. A mission to Mars that currently takes around 7 months could potentially become much shorter, reducing astronauts' exposure to harmful cosmic radiation and the health risks of spending long periods in microgravity. Nuclear-powered spacecraft could also carry heavier scientific equipment, larger habitats, and more supplies without sacrificing performance. However, these technologies also come with enormous engineering challenges. Engineers must build reactors that are powerful, reliable, and safe enough to operate in the harsh environment of space. They also need to ensure that launches carrying nuclear materials meet the highest safety standards. Although many of these propulsion concepts are still under development, they could become the key to humanity's future beyond Earth. Now let's move to number 6, classified space shuttle missions. Most people remember NASA's Space Shuttle program as a symbol of scientific discovery and international cooperation. But not every shuttle mission focused solely on science. During the Cold War and the years that followed, several space shuttle flights carried out classified missions in partnership with the United States government. These missions often deployed military or intelligence satellites whose purposes were kept secret for national security reasons. Even the astronauts involved sometimes knew only the information necessary for their specific tasks, while many mission details remained classified for years after the flights ended. These classified missions demonstrated just how versatile the space shuttle was. It wasn't only a vehicle for building space stations or conducting scientific experiments, it also became an important tool for national defense. While many details have since been released, some aspects remain undisclosed even today. These missions helped improve satellite deployment techniques, orbital operations, and spacecraft reliability. They also highlighted the close relationship between civilian space exploration and national security. Although these launches attracted less public attention than famous scientific missions, they quietly contributed to advances that continue to benefit modern space technology. Halfway through our countdown, we arrive at number 5, Project Timberwind. During the late 20th century, scientists began exploring revolutionary propulsion systems that could outperform traditional rocket engines. One of the most intriguing programs was Project Timberwind, an advanced research effort focused on nuclear thermal propulsion. The goal was to develop engines capable of generating significantly greater efficiency than conventional chemical rockets, making future missions to Mars and beyond much more practical. Unlike ordinary rocket engines, which burn chemical fuel to produce thrust. Timberwind explored the idea of using a nuclear reactor to heat hydrogen fuel to extremely high temperatures before expelling it through a rocket nozzle. This process could create much higher efficiency while carrying less fuel, allowing spacecraft to travel farther with greater speed. Because the research involved advanced nuclear technologies and potential military applications, much of the program remained highly restricted during its early years. Project Timberwind faced enormous technical and political challenges. Engineers had to design reactors that could survive intense temperatures while remaining lightweight enough for spaceflight. At the same time, public concerns about launching nuclear materials into space created additional obstacles. As government priorities changed and budgets shifted, the project eventually lost momentum before reaching operational status. However, the research was far from wasted. Many engineering concepts developed during Timberwind influenced later nuclear propulsion studies and continue to inspire today's advanced spacecraft designs. These first three projects reveal an important truth about space exploration. Many of NASA's most ambitious ideas never became household names, not because they lacked potential, but because they were simply too advanced, too expensive, or too sensitive to be widely discussed at the time. Yet the knowledge gained from these secret programs continues to shape modern engineering and future missions. Technologies once considered impossible are now becoming realistic goals as humanity prepares for a new era of exploration beyond the Moon and Mars. But the countdown is far from over. In the next part, we'll uncover NASA's plans for building nuclear power systems on the Moon. Explore the revolutionary Nerva nuclear rocket engine that could transform interplanetary travel. Revisit the incredible dinosaur spaceplane that was decades ahead of its time. And finally reveal the #1 secret NASA project that many experts believe could have changed the future of space exploration forever. Welcome back! So far, we've explored NASA's future nuclear propulsion concepts, classified space shuttle missions, and the ambitious project Timberwind. Now, it's time to reveal the top 4 secret NASA projects that captured the imagination of scientists and engineers around the world. These groundbreaking ideas push technology far beyond what most people thought was possible and continue to influence space exploration even today. At number 4 is NASA's lunar nuclear reactor plans. Returning humans to the Moon is only the first step in NASA's long-term vision. The real challenge is keeping astronauts alive on the lunar surface for months or even years. Unlike Earth, the Moon experiences nights that last about 14 Earth days, making solar power alone unreliable. To solve this problem, NASA has been researching compact nuclear reactors that could provide continuous electricity regardless of sunlight. These reactors are designed to power habitats, scientific laboratories, communication systems, mining equipment, and even future lunar factories. Although the concept may sound futuristic, nuclear reactors are one of the most practical solutions for long-term space exploration. A small reactor could generate reliable power day and night while surviving the Moon's extreme temperatures. Engineers have spent years studying how to build systems that are lightweight, safe, and capable of operating without constant human maintenance. Developing these reactors is incredibly challenging because every component must survive rocket launches, space radiation, lunar dust, and harsh environmental conditions. If successful, this technology could become the foundation of permanent human settlements on the Moon and later support missions to Mars. Moving to number 3, we find one of NASA's most famous experimental programs, Project Nerva, short for Nuclear Engine for Rocket Vehicle Application. During the 1960s and early 1970s, NASA and its partners worked on an engine that many experts believed could revolutionize space travel. Instead of burning chemical fuel, Nerva used a nuclear reactor to heat liquid hydrogen into an extremely hot gas, producing far greater efficiency than traditional rocket engines. What made Nerva remarkable was that it wasn't just a theoretical design, it successfully completed multiple ground tests. Several prototype engines operated for extended periods and demonstrated performance far beyond conventional rocket technology. Scientists believed that spacecraft equipped with Nerva engines could significantly reduce travel time to Mars while carrying larger crews and heavier scientific equipment. However, despite its technical success, changing political priorities and reduced funding following the Apollo era led to the project's cancellation before it could fly in space. Even though Nerva never reached operational status, its legacy continues today. Modern nuclear thermal propulsion research builds directly on the knowledge gained from this pioneering program. Many engineers still consider Nerva one of the most promising propulsion systems ever developed, and future missions to Mars may finally bring its concepts to life decades after the original project ended. At number 2 is the incredible Dyna-Soar X-20 program. Long before reusable spacecraft became a reality, scientists envisioned a winged vehicle capable of launching into orbit, completing missions in space, and gliding back to Earth like an airplane. The Dyna-Soar program was created to explore this revolutionary idea. The spacecraft featured an aerodynamic design that would allow it to survive the intense heat of atmospheric re-entry while remaining reusable for future flights. Although the program was eventually canceled before its first launch, Dyna-Soar introduced technologies and engineering concepts that proved invaluable in later decades. Its research influenced the development of reusable spacecraft, advanced heat shields, precision guidance systems, and even aspects of the Space Shuttle program. Many aerospace historians believe the Dyna-Soar project was simply ahead of its time. If it had continued, reusable spaceflight might have become a reality years earlier than it actually did. Finally, we arrive at number 1, Project Orion, one of the boldest spacecraft concepts ever imagined. Unlike any rocket built before or since, Project Orion proposed using controlled nuclear explosions as a method of propulsion. The spacecraft would carry a large number of specially designed nuclear pulse units. These devices would be released behind the spacecraft and detonated at carefully calculated intervals. A massive shock-absorbing plate at the rear of the spacecraft would absorb the force of each explosion, pushing the vehicle forward with tremendous power. At first glance, the idea sounds almost unbelievable, but scientists performed extensive calculations showing that the concept was physically possible. Project Orion promised performance far beyond conventional rockets. Massive spacecraft weighing thousands of tons could potentially travel to Mars in weeks instead of months and even explore the outer planets with unprecedented speed. Some scientists even imagined interstellar missions using enlarged versions of the same technology. However, the project faced overwhelming obstacles. Concerns about radioactive fallout, international nuclear treaties, environmental risks, and public safety made practical development nearly impossible. As global attitudes toward nuclear testing changed during the 1960s, Project Orion was ultimately abandoned. Nevertheless, it remains one of the most fascinating engineering concepts in the history of space exploration. Even today, aerospace experts study Orion as an example of how bold thinking can expand the limits of what humanity believes is possible. Looking back at all 7 projects, one thing becomes clear. NASA's greatest innovations are not always the missions that make newspaper headlines or appear on television. Many of the agency's most ambitious ideas were hidden behind classified research, experimental laboratories, and decades of scientific development. Although some projects were canceled and others remained secret for years, each one contributed valuable knowledge that continues to shape the future of space exploration. The spacecraft, engines, and technologies of tomorrow may owe their existence to ideas first imagined generations ago. As humanity prepares to return to the moon, build bases on other worlds, and eventually send astronauts to Mars and beyond, some of these once secret concepts may finally become reality. What once sounded like science fiction is steadily moving closer to becoming science fact. Which of these secret NASA projects amazed you the most? Let us know in the comments below. If you enjoyed this documentary, don't forget to like the video, subscribe to the channel, and turn on notifications so you never miss our next journey into the incredible world of science, technology, and space exploration. Thanks for watching, and we'll see you in the next video.